Solving a quadratic equation, or in another sense, solving a polynomial equation, requires us to take our factoring skills from the last couple of lessons and combine that with our understanding of a new principle, the zero product property. Let's begin with a fairly straightforward factoring quadratic equation that needs to be solved. 2x squared minus 5x is equal to 12. In order to apply the zero product principle, we need to have an equation that is equal to 0. To do that, we subtract 12 from both sides of the equation, and now we have an equation that equals 0. Once we equal 0, this is where we will look to factor, as we will create the two factors that will multiply together to make 0. Using the AC method, you can multiply 2 and negative 12 and get negative 24, and then you'll be looking for a product of negative 24 and a sum of negative 5. Cutting out a lot of that long work, we get that the factorization of this polynomial is 2x plus 3 and x minus 4. Reinforcing the zero product property, right here is a multiplication. Because this product equals 0, we know that either this binomial or this binomial must equal 0 in order for the entire polynomial to equal 0. This essentially amounts to us solving two smaller equations, one that says 2x plus 3 is equal to 0, and another that says x minus 4 is equal to 0. The solution to the binomial equation on the left, x equals negative 3 over 2, and the solution to the one on the right, x is equal to 4. We have two solutions that would work for this polynomial. We can check both of them, and I will always advise that when you check a solution, you go back to the original version of the equation to make sure that it is true. In this case, both of these would work, and you can back substitute both of them to check. And if we wanted to write our solution in a solution set format, we would say our solutions were negative 3 halves, and positive 4. Trying another one, here we have 5x squared equals 20x. Again, we have a quadratic equation where our highest power is the second power over here on the left. We're going to set this equal to 0 by subtracting the 20x from both sides, and then we're going to factor. Before we begin factoring, looking for difference of squares or anything else, the difference of cubes, those strategies and patterns that we're used to seeing for binomials, we're going to look and notice that this first has a greatest common factor of 5x. We remove that 5x from both of the terms, leaving us with x minus 4. Nothing else is going to come out of this binomial. That binomial is fully factored. So we have two equations, again, to solve, looking to get 0 as our answer. We could have 5x equal to 0, or we could have x minus 4 equal to 0. Well, this one we just saw in the last example means that x could be 4, or over here we would get that x could be 0. Again, writing our solution set of 0, 4, and recognizing that we could go back and test those answers to make sure they work, which they do. The one thing you're going to want to avoid doing, and this is not allowed, and I'll explain why in a second, is a lot of people see the common factor of x on the left and on the right, or even the 5x, and they attempt to divide it away. And they say, well, if I'm going to divide by x over here, that gets rid of this x, then I'm going to divide by an x over here, that gets rid of the square, and then I'm left with 5x is equal to 20, and then x is equal to 4, and they get all excited that they got an answer. But if you compare our answer to the answer over here, it looks like when we divided by x, we lost the solution, and that's exactly what happened. Well, why did that happen? Well, if you're looking here, and then you look at what that other solution was that we lost, we're not allowed to divide by 0. And essentially, that's what we did. Because x ends up being 0, we essentially divided by 0. We divided away one of the possible solutions. We do not want to engage in this behavior because the x could always be equal to 0. Unfortunately, for equations like this, quadratic equations like this, or polynomial equations like this, we have to go the long way. We can't divide away an x and pretend that the x could just be simplified out of the equation. That's one of the answers. The reason that we got two answers down here was because of that quadratic power. It's not always going to work like that. You'll see examples where there's a quadratic power and the answer is repeated. It's the same answer twice. You'll see some that have the quadratic, and they don't have any answers. There's no solutions. But we don't want to engage in behaviors that could potentially divide away a solution so that we can't get it. We want to go the long way. Set it equal to 0, factor, solve the two small equations, and look for when we can apply the zero product property.